Hello everyone, my name is Pratiksha and my topic for video presentation is the evaluation of solar farm locations, applying geographic information system and multi-criteria decision making methods. It's a case study in southern Morocco. So we'll start with the solar farm. So what is the solar farm? So solar farm is basically a large scale solar installation where photovoltaic panels or concentrated solar power are used to harvest the solar energy. So they are also known as solar power plant and solar park. So what solar farm basically does is it converts the sunlight like light energy into electricity. So it's a medium for renewable energy. Like we can use solar farm to convert the renewable energy, that's the sunlight, for production of electricity. So here you can see the two the different types of modules, or we can say objects that are used in solar farm. Like one is this photovoltaic module. So there are basically solar cells, which are there are so many solar cells and which make solar panel, and that are we commonly call a photovoltaic module as solar panel. And the second is the concentrated solar power. Here we can see that. So it's in concentrated solar power. It's basically a tube shape panels or tube shaped object which uh, absorbs the sunlight and absorbs the heat, and it converts it into the electricity. So next is the GIS. So what is GIS? GIS is basically a geographic information system. So it basically allows user to create interactive queries, then edit and store special and non-special data, then analyze and visualize geographic data. So it basically works with the geographic information databases, and there are several GIS tools that are used to handle geographic information. One of them is QGIS. It's open source GIS software which is used for mapping purpose. It's a very common and popular GIS software. So as I told already told that it's used for analyzing and visualizing the geographic data. So there are two types of data. So one of them is raster data and second is the vector data. So here you can see the raster data. So raster data is basically it uh, breaks the whole area into different pixels, or we can say it's a grid of rectangles which are of the same size, and that rectangle, or we can say the square, it is called as pixel or cell, and each that cell contains data. And the raster data is mainly used for representing the dense data like land cover, like the land under the vegetation, like forest, wetlands, then the elevation like slope, any kind of mountain. So we can use raster data for that kind of uh, area or that kind of dense data. And second is the vector data. So vector data is basically it uses points, lines, and polygons to represent the data. So it closely resembles with the real world. Like uh, we can take the example of building full footprint. Like we can draw the points and then connect it, and it will make a vector. Like it will be a kind of a geometrical shape. So that is what is vector data. And is in vector model, geographic features in GIS are expressed as vectors. So that I told. So as we can see here, it's good at representing discrete data. As I already told, building footprints, streets, then uh, streams are some examples. So here we can see the real data and the digital model. So that's in the image. Then now the MCDM. So MCDM is basically multi-criteria decision making. So what is multi-criteria decision making? So it's basically considering multiple objectives or criteria together in order to rank or choose between the alternatives. uh, and like there it's like there will be very when we want to find out the solution for any kind of problem, we need to take different alternatives, like different kind of solution into consideration. And for choosing the uh, best solution for that problem, we use multi-criteria decision making. So it basically concerned with structuring and solving the decision. And MCDM, that is the multi-criteria decision making, support decision makers, like where there are this is the one of the role with the industry or in any kind of field, like where there are the experts who needs to take the decision for any kind of solution. So they take the help of the multi-criteria decision making process. So, analytical hierarchy process, weighted sum model, weighted product model, these are some methods of multi-criteria decision making. So, analytical hierarchy process is one of the MCDM method, and it is very popular and the common method used. So, here we can see the steps for applying the hierarchy, analytical hierarchy process. So first step is to select is selection of goals. So like what we are looking for. So what is our end product? Like what end product we want. So we need to select the goal, like what we are actually looking for. Then we will find any kind of solution, and then we need to there will be so many different solutions for a single problem. So we need to select the most most suitable alternatives, like which are good. And then after that we need to select the decision criteria, like for any kind of solution there will be different criteria that into consideration, that we need to uh, select the criteria, and we need to apply the pairwise comparison of criteria. So here we can see in the left side there is a pairwise comparison of criteria. In the right side, pairwise comparison of alternatives using each criteria. So for a for a criteria there will be alternatives, right? So firstly we will compare between the different criteria, and then the inside the each criteria we will compare the alternatives. And if we found the comparison consistent, the like after that we will check the consistency. So if we found the pairwise comparison consistent, then we will make the comparison matrix of criteria. And similarly we will do the same for the pairwise comparison of alternatives, like of using each criteria. And then after whole this comparison matrix, once the comparison matrices are created, by comparing both and by embedding both, we will found the most appropriate alternative. So here, so these all comparison, like I say, the pairwise comparison are done by using the Satis discrete 9-value scale. So it's uh, so here we can see the rating scale like 1 to 9, and the equivalent definition for that scale, like if the rating scale is 1, then it's the equal importance. It's between the pairwise comparison. So when we compare the criteria or alternatives, we take the help of this rating scale, like we scale those on the basis of this Satis discrete 9-value scale. Then here the consistency check. So here we can see the different formulas, like estimate the consistency index using estimated consistency index using so this is the formula like lambda max minus n divided by n minus 1, and the other one is cr equal to ci by rc. So here you can see the one statement I have given, that if CR is less than equal to 0.10, then the data is considered to be consistent, and otherwise it is considered to be inconsistent and it needs to be revised or rejected. So I'll just give an example like what is consistency check. So basically, like if I say that liquidity is twice as important as protection from downfall. And in the next matrix, I say the protection from downfall is half as important as chance of appreciation. So when we imagine the both situation, it will be like liquidity equal to 2 times protection from downfall, and the protection from downfall equal to half the chance of appreciation. So when we imagine both the things, we found that liquidity is equal to the chance of appreciation. Like what it means, like liquidity must equal chance of appreciation. And if in the pairwise comparison, like here we can see the we are comparing the two pairs, like the two criteria. So if in this pairwise comparison of liquidity and chance of appreciation, if I given a weight of more or less than one, then my data will be considered as inconsistent. Like if the according to the these situations, if I don't give the weightage to each thing, like if I given liquidity 1 and 2, chance of appreciation 2, then my data will be inconsistent, as we found the situation where liquidity must be equal to the chance of appreciation. So that's what the check consistency check. And then according to that, we assign the weights to each criteria. So here we have considered four criteria in this research. Like here we are trying to find out the location for solar farm. Like what is the most suitable location for solar farm in southern Morocco. Like so, the first criteria was taken into consideration was climate. So the climate was found to be hot and semi-arid, and so then the location. The location is like here we considered the two different factors like distance from city and like distance from town, and or we can say urban area, and the distance from roads. So as we know, when here we are trying to generate the electricity, and as long as the distance from road or urban area is less, it will be easier and more profitable for generating the electricity in that area, as the transmission lines will be less and the transportation will be easy. So that can, for that purpose we consider the location. And the climate we consider because here we are using the sunlight, so we need to uh, consider the where the solar radiation is more and where it's not. So one, if we consider the region where solar radiation is very less, and then it won't be of any use for any kind for generating the electricity, as solar panels will absorb less energy, then they will generate the less electricity, so that will be of no use. Then the third criteria is the land use. Like land use is basically how people are using the landscape, like whether they are using for development or any kind of conservation. So that's what is land use. And according to our research, we need to consider the land use as uh, how, as long as the urban areas are near to our project implementation region, it will be of very good use, as we here we are trying to supply the electricity to the town, to the whole country. And here we are trying to reduce the dependency on the fossil fuel. Like uh, Now, what is the actual purpose behind this research is to reduce the dependency on the fossil fuel. We want to move from the fossil fuel to the renewable energy, as there is too much pollution as well as the reduction in fossil fuel. That's why we are doing this research, right? So that's why here we are considering the land use. Then the fourth criteria is orography. So it's basically a branch of geography which is dealing with the formation and features of mountains. So here what is the use of orography is, here we are trying to find out the slope and slope orientation. So as we know, the solar panels are in the inclined position. So here we are trying to find out the slope. So where the solar radiations are more, and the slope orientation as we want the slope. So that's for that purpose here we are considering the orography. Now here we can see the criteria and the factors and the indicators. So as I said, the land use. So it's the indicator is the area without vegetation. As land use is the how people are using, where land cover is the like the area which is under forest or wetlands or any kind of natural resource. That's what is land cover. But here we are considering the land use. So then the second, you can see the second criteria is orography and the factors like slope, and the we found these 4 to 5 like indicators, we can say, like 0 to 4% slope, then 4 to 8% slope. So this all information is used to create different criteria maps. So here second is second factor for orographic slope orientation. So where is the slope orientation? Like it is from it is in the south or it is in the southeast. So according to that, there are around 7 different indicators. Then the location, like distance to urban area in a kilometer, it is given like 0 to 1.5 according to that. Then the distance to road, like how away the road is from our location, like decided location. Then the climate, as I say, we are considering the solar radiation. So where is the most solar radiation in the our considering region? So in that way, we are considering the factor potential solar radiation and the land surface temperature, as solar panels are absorbing the heat like sunlight as well as the heat. So land surface temperature is also important to consider. So here you can see, as I already discussed about the pairwise comparison. So here we are comparing the criteria. So different criteria are compared here, and according to that, the result of the matrix is given. And in the last column, you can see the weight, like in the percentage, like by using the AHP, as I said. So here we are. What are we trying to do is to assigning the weights, like what is the most important for the our research or uh, for getting the output that we want. So here you can see the weightage. So for climate it is 59%, where for orography it is 25, land use 11, and location is 5%. So here you have clearly get the idea that climate is the most important factor, most important criteria that we need to take into consideration while deciding the location for our project. So according to that, you can see the ranking, like first is the climate, then orography, then land use, and then the least we can consider is the location. Now here you can see the factor weights, like according to factors there are weightage are given. Like for land use 5% weightage is given, slope 11%, slope orientation 7, distance to road 6, distance to urban area 7, then potential solar radiation 42, and land surface temperature 22. So if you sum, if you do the summation of all these weightage, it will be 100%. So we are dividing the 100% into the uh, different weightages, like different percentage, to consider the what is the most important. So here you can see in factors, potential solar radiation is the most important weightage, as it's obvious, like we are here trying to convert the energy into electrical energy, so we need solar radiation. So here are the criteria maps that I just discussed in this table. Like the indicators are actually from the maps. Like we have done this, and so actually the authors done this. So here you can see the land surface temperature. So from minus 15 to 0, there is uh, light yellow, then bit darker like turmeric yellow. So in that way you can see the different colors representing the different temperature, like temperature range. Then here you can see the potential solar radiation ranges. So here it's darker, like you can see in the uh, north direction it's more darker, and a bit lighter also. So here now you can see the slope orientation, like in the north, in northeast, east. So the indicators we already discussed, like, and then here you can see the slope, like where is the slope, what is the percentage of slope. Uh, so we are considering most slope. We are here looking for the slope area which has the minimum slope, as flat area is most suitable for this project. As I already discussed, the panels are already inclined, so when there is a flat surface, all panels will be on this will be in the same alignment, and the energy that they will absorb will be of the same amount. So that's why flat region will be more suitable for this project. Then here you can see the vegetation indices. Like while installing in this kind of project, we need to take consider the natural resources or natural habits that are already there. So uh, here you can see the land use. So here we are neglecting those areas like which are already a natural habit. Then here you can see in uh, greenish yellow there is no one project, like one this project is divided into three phases, where first phase is already installed in 2015. So we need to, and there is no more there is not enough space for installing the second and third phase. So we need not to consider that area. So here you can see also waterways are there. Then Acumen and one more is there. It's not visible clearly. So those two things, like the in red, in pinkish color, and the one in quite black gray color. That two things are the natural habitats. So those two things we are again not considering. Now here you can see the result. So after doing the whole calculation, like doing the MC, like using AHP to assign the weightages, then finding the proper. So here everything is doing going around the weightage, like the most weightage to the particular criteria, that will be considered to be a suitable thing. So you can see the versus Z Morocco. It has the highly suited. It has the maximum percentage of in the row of highly suitable, and In Murcia, it has 3%. In Granada, it's 5%. And Carapina is 14%. But the Ouarzazate has the 23%, and it's in the southern Morocco, as we have it's our case study. So it found to be highly suitable. So the result of the whole research is was to find out to the whole like the purpose of this whole research was to find out the proper and suitable location for installing the project, for developing this project. And the budget was found to be a suitable and perfect region, perfect location uh, in the Morocco, in the southern Morocco. So here you can see the land suitability levels, like the one in the orange color is unsuitable, the marginally suitable. So the one you can see in the dark purple, which is here, mm, which, okay, so which is here, is the highly suitable, and that's what's the was it area. So that's what we are consider. That's what we will be considering for the installation of this project. So that's the project of my top that was the topic of my project. So thank you so much.